Okay, well, good morning, everybody. Thanks for coming. How y'all doing? Yeah, everybody get here for the 8:30 sessions and been here bright-eyed and wide awake for this? Okay, so my name's Cameron Brett. I've been in the storage business for a long time. I'm president of SCSI Trade Association, and I presented here a number of times before. So is there anybody here that is not familiar with SAS? I assume here that, I mean, it's been around forever, but you know, maybe some of the younger people may not be as familiar with SAS as some of us who've been around a little longer. Okay, there's been, of course, you know, NVME has definitely been a big focus in recent years, and NVMe OF. You know, SAS isn't always part of that conversation, and you know, for full disclosure, although I am president of the SCSI Trade Association, I'm also co-chair of the NVMe Marketing Committee. So I do both. I also am part of SNIA for the SSD SIG, along with John Michael Hands from Intel. This presentation really is meant to kind of just remind developers at how pervasive SAS is. It is still being innovated, and new features to work in the data center, not just the traditional data center. And so SAS is, you know where SAS is commonly used today and has been for its tried and true. But there are some places that you may be surprised where SAS is actually used. And so this presentation is, don't forget about SAS. Does anybody hear that SAS is dead? Couple? Anybody else? Okay, I hear that. Yeah, I mean, we all know that SATA is, on its long tail out, right? There's no turn at the crank speed on that, and SAS still has a roadmap, but the reports of SAS's demise is not totally untrue, but not totally true either. So this is from May of this year. This is from IDC. And the different categories here, really, if you look at the SAS infrastructure, it consists of SAS and SATA, hard drives, and SSDs. In IDC's definition of enterprise, it includes traditional enterprise as well as hyperscale or scale-out data centers. So if on that definition, the green is PCIe, and everything else basically is SAS or SATA. So there's definitely, you can see for the foreseeable future, SAS is still going to be deployed in some way, shape, or form. When I talk about SAS technology, it's not just the drives. It's HBAs, RAID cards, expanders, things of that nature. And even from a gigabyte capacity or terabyte capacity standpoint, the SAS infrastructure, whether it be SATA, SSD, SATA hard drives or SAS hard drives, is still growing. They're still very useful technology. If anybody has any questions, we can talk. Just raise your hand. We'll dig right into it. We don't have to wait and hold it till the end. So we'll be a little less formal. So this is, I think, how everybody knows SAS in the storage world. Of course, in servers, you could have direct attached storage, but this is kind of your classic storage area network where you've got the ability to share. This is very widely deployed in traditional enterprise. So this is how I think most people are familiar with it. Is this new to anybody? I would not think so. Just a little bit of a closer look inside the box, and basically, on the right-hand side, the drives could be SAS, SATA, hard drives, or SSDs. Now, of course, what makes SAS really so universally developed over the years is because it is so flexible with utilizing SATA over the SAS infrastructure. And this is really a SAS infrastructure. This is inside a storage box, SAS expander, SAS IOCs, And if you're going to a SAN, then this NIC is a fiber channel or iSCSI. And then if it's direct attached, then this is just a SAS HBA. So this is a very, very common way of deploying SAS. Is this new to anybody? Over time, NVMe will, have more of a place in the external storage space. There's a lot going on with NVMe over fabrics, but SAS is still predominantly used, whether it be SAS or SATA storage. Now, in the hyperscale space, SAS is actually specified in a number of designs. This system here is developed by WeWin. This is the Honey Badger, based on the OCP specification. This one is a few years old, and so they specifically call out, utilizing SAS drives. The SAS infrastructure, lots of expanders. And so this one in particular is up to 30 drives. And then a more recent version of a storage server is Bryce Canyon, 12 gig SAS, again specified, with 72 hot pluggable drives. And so you can see it's a lot more dense, but it doesn't have to, when we're talking about SAS, it doesn't have to be SSDs or compared to NVMe SSDs. So this is also based on the Facebook storage system specification. So how many people knew that SAS is actually specified in OCP? A lot of people aren't aware of that. So it's interesting to see, how pervasive SAS is in the data center, not just the traditional data center, but in hyperscale and scale out. Who works for system companies here? Develop. So I know these guys make servers and systems. Okay. Who do you work for? Okay. And you? Seagate. Okay. Others? So is SAS still part of the development systems? Yeah? I'm sure at Seagate you guys still have a vested interest in SAS, and I was talking to these gentlemen up here earlier, and they still specifying SAS. Okay. A little bit of a closer look at the block diagram of Bryce Canyon. And this is actually one system. It's not two systems. There's just two sides to the system. And this portion right here is where it calls out the SAS components. This is the SAS infrastructure. Again, this is a very traditional going across PCIe. But if you look at the number of drives that are supported in here, technically you could put SSDs in there, but this is mainly for a specific type of storage server. So this particular diagram was pulled from actual Facebook website, facebook.engineering.com, talking about the OCP designs with Bryce Canyon in particular. Does anybody build these types of hard drive systems, or are most people developing, or who's building hard drive-based systems still? Okay. Who do you work for?
So my company consults for MEC.
Okay. Okay. And who else raised their hand? Okay. So Seagate. Okay. Yeah. So hard drives are still going to be used quite a bit probably for the foreseeable future. Just like tape has an extremely long tail, and tape is actually there's a lot of development going on in tape. So touching back a little bit more at the application level, this is subjective. It's a bubble chart, we call it. Along the x-axis, this performance is from low to high, and you can think of this generally as IOPS as well as throughput. And on the left, the y-axis is the level of read versus write, and the size of the bubble kind of shows the general range of the read versus write and the range of performance. So obviously, the hard drives are going to be kind of more in this kind of lower performance, probably a little bit more read intensive as opposed to write intensive. How many folks are familiar with 24 gig SAS? Okay, I certainly expect Seagate to be familiar with that. They're on the SCSI Trade Association. So 24 gig SAS is something that's coming. I'll touch on that a little bit more. But 24 gig SAS, are people familiar with what the differences are between 24 gig and 12 gig SAS? Yeah. Aside from the obvious 12 versus 24, there are a number of updates going to the new spec, and you'll also notice that we're going to 24G as opposed to 24GB/S. Traditional SAS has been like 6GB/S, 12GB/S, and that's because we're calling this more or less a 24 gig kind of class. It's not true 24 gig throughput. The baud rate is 22.5 due to encoding reasons. But 24 gig SAS actually, on a per lane basis, is the fastest interface. NVMe is typically deployed in a by 4 arrangement, and when you combine 4 PCIe lanes versus 1 SAS lane, the performance is going to be greater. But here's some just an example in some cases where 24 gig SAS could prove to be kind of better positioned than traditional SAS. Yes.
Is 24 gig SAS also changing the encoding, physical encoding?
Yes. Yes, you're correct. I have one slide that kind of touches a little bit on that, so we'll get that in momentarily. So this is a look at this slide, and the next slide is a look at various application workloads. And so this chart was worked on with some friends over at Broadcom, looking at the applications, just kind of a descriptor of the workload characteristics. So machine learning, again, these are generalizations. There may be some specifics that your application or a customer's application may be different than this, but as a general characteristics of these types of workloads. So we look at characteristics for like machine learning, lots of highly paralleled reads, and so direct attached is good for that. And then we just have this kind of block chart that kind of shows whether it's small or large sequential reads, small or large sequential writes, random reads and random writes, and so forth. And so we kind of use this as a nice reference for to get an idea of what types of drives. And so the storage requirements, we specify whether it be direct attached or RAID attached, or perhaps just straight I/O, SAS I/O. But in some cases, SATA is fine, but you can utilize that behind a SAS infrastructure. Over on the right here, the storage performance objectives kind of says what is it really doing? What's the next level down of what the application is doing? Generally speaking, this is a nice little reference chart. So this will be available after this session. I may be online right now, but I think I've updated it since the last one. Actually, a question?
When you talk about large databases, what is the size?
Like in the perhaps could be up to hundreds of terabytes.
In terms of block size, it's small. I know 8 gig was standard at 15.
Yeah, probably over time as the newer applications come out. But typically when like in this particular case, maybe 8, perhaps 4K block sizes or less. Is there anything that's surprising on this chart here? Or is this kind of generally intuitive?
I mean, for the first 3, are you saying there's no data protection or software data protection?
No, it may be done. It may be done at a different level. A lot. In some cases, hardware RAID is used. In other cases, software protection mechanisms may be in place. Yeah, I mean, certainly see in like the case of financial trading, you definitely want some level of data protection there. Yeah. Okay. Yes.
For written rewrite, do you think SAS and SATA can fulfill the performance requirement
For which one?
for SAS and SATA RAID?
Uh-huh.
I wonder if they can fulfill the random I/O performance.
Well, okay. So the question is, will SAS and SATA be able to handle the performance requirements for some of these applications? The short answer is SAS and SATA has been managing the performance requirements for many, many years. Now, what I'm not calling out here is I'm not comparing NVMe to SAS or SATA. I think everybody knows that NVMe has higher IOPS and faster throughput. This is just showing options for this, what you'll find and how you can deploy this in a SAS infrastructure. So I think that to answer your question, SAS and SATA has been able to handle the performance requirements for these applications for many years. But can you do better? I think the answer is yes, you can do better with NVMe. But NVMe has not quite the maturity that the SAS infrastructure has from like a management perspective and a scale-out perspective. So that'll probably happen over time. I think we all fully expect that too. But based on history and up through today, maturity of the SAS interface is still probably the most pervasive and the most stable.
What's the reason for recommending SATA for machine learning?
It is. Yeah.
Cheap drives, and with enough of them, you get enough bandwidth.
Yeah. I have to. Well, that's a lot of the way the cloud architectures are deployed. Striping across large amounts of drives, and that's sufficient.
But you aren't necessarily saying that that's recommended. It's meaning that you can get down to that level.
Yes.
And still meet the need.
Yes. Exactly. Just to reiterate, you're saying, this chart is not meant to say what is the optimal, but what you can get away with or you can live with for these types of applications.
What you're recommending really is that this is a matrix by which you can figure out what the engineering and economic trades are and still meet the application.
You can meet the application's basic needs in a SAS infrastructure. So all the slides here do not mention NVMe, although of course you can deploy NVMe. When I speak on behalf of NVMe, then I'll probably be promoting NVMe and not so much SAS. This is just the second chart. I'm not going to walk through this, but it does have additional workloads that are pretty common in whether it be scale out or traditional enterprise. And feel free to take pictures, but these slides will be available online. So does anybody work directly with some of these types of applications? in maybe more in a vertical sense, as opposed to like, like a system builder that will support multiple applications. Yes?
I deploy large databases and big clusters.
Okay. How large are those databases typically? Half a peta. Okay. Okay. And from your experience, I guess the recommended or some of the base requirements is do you utilize SAS and SATA today?
Yes, but I'm not using spinning disks.
Okay. Okay. So you may be utilizing SAS and SATA SSDs or SATA SSDs behind us, SAS expanders types. Okay. Okay. And what are the more important requirements? Is it performance? Is it small blocks?
I've done two types of things, right?
Mm-hmm.
I've built backup systems, but I don't call them backup systems.
Okay.
I call them restoration systems.
Restoration systems. Okay.
I call them restoration systems is because if I have an outage
Mm-hmm.
that I need to restore, my time to recovery or time to restore is much more important than my time to backup.
Right.
So one of the things that I was looking for is, which I did not see, and I kind of see there at the bottom, is large reads and large writes.
Mm-hmm.
Right? Those are the two predominant use cases for my backup and restore things. And
Okay.
it's mostly, most of the time, it's just backup. When blank hits the fan, you know you need to go get the restore to work.
Okay.
And to work really well and really fast. And it's most of the times, database backups are very sequential in nature, and
Right.
restorations are very sequential.
And scale of the data volume that you're using has to recommend a more economical approach, but you can't lower your recovery standards too much.
Recovery standards can't be lowered. Cost point needs to be tracked.
But it's secondary. It's never secondary.
Cost is never secondary is an appropriate statement. But I appreciate that you care about performance also. Right? Performance actually takes precedence over cost.
Because that's going to drive the very direct but unexpected cost.
Yeah.
on the campus.
Yes. I mean, backups are never thought of very, as important, if you think about it from a business perspective, until things go wrong, at which point they become really challenging.
Mm-hmm.
And my take is that too many backup systems companies are building solutions where they're failing to disclose recovery rates. They only talk about backup rates.
Right.
I'm like, why is this broken?
Right.
Okay.
Time to recovery
Time
is
to recover
is
far more
extremely important.
And I understand all the optimizations you're trying to do to reduce my disk space needed and power
Mhm.
utilization from a backup perspective, and you're trying to improve backup performance, but my most critical thing is restore performance.
Right. Well, thank you. Yeah, that's a very good point. Does anybody else work with any other applications directly on this? Love hearing feedback.
Yeah, it's very similar. I mean, we've got several fairly large ones, 300-400 terabyte analytical environments. But like you said, part of it is building the disaster recovery because disk to disk before we dump it off to some other media. Because if you catch it quick enough within a couple of days, we're more worried about recovering data in a timely manner than we are just a backup.
Mm-hmm. Right. Okay. Okay. All right, well, thanks for the discussion on that. Okay, 24 gig SAS. Just a little bit of background on us. These are some of the enhancements that are made to 24 gig from upgrading from 12 gig SAS. And really just touching on these two layers, the physical layer and the protocol/block level. Of course, the physical layer enhancements include doubling the effective bandwidth up from 12 gig with improved encoding and 20-bit forward error correction. The physical layer enhancements deliver higher IOPS and bandwidth performance, as well as improved reliability. On the protocol and block side, fairness updates help improve performance across multiple generations. One of the SAS's value propositions is backward compatibility. And this is something that we strive to maintain every generation, going back 2 generations, which should cover basically the usable whatever is currently deployed, unless somebody's still deploying like parallel SCSI or something. Is anybody still utilizing parallel SCSI? Yeah. Now the performance improvements across multiple generations of devices in larger topologies. So it's like when you have multiple layers of expanders with large drive deployments. So this includes SAS and SATA, as well as hard drives and SSDs in the same deployment. Storage intelligence enables more efficient streaming and data management. Those familiar with storage intelligence, kind of being able to manage some of the activities, the background activities on drives, SSDs. Translates into improved SSD efficiency and the quality of the storage performance throughout the topology. SMP priorities also helps improve the prioritization of configuration and management communications. So that's it. That's kind of I'm sorry, do you have a question?
For the fairness enhancements, which specific parts of the spec does that represent?
I'm sorry, which one again?
Fairness enhancements.
Okay.
The first one is protocol and block.
Right.
So which specific features in SCSI does that talk about? That's new in 24G.
Let me get your name and get back to you on that for some of the specifics.
I think a lot of that has to do with fan out across multiple tiers of expanders. In the past, it was a per link fairness algorithm, and now the leaves in the tree drive the allocation of time.
So that's entirely in the expander part, not the target.
Well, it benefits the target, but it's all within the expander plan. Yeah.
Okay. Thanks for jumping in. There are continued innovations in hard drives and SSDs for SAS. A lot of these acronyms and terms are maybe familiar, but these are innovations that are still happening today within SAS. So it's obviously not a dead technology. There's going to be innovations going on for many years to come, whether it be solid-state hard drives. We talked a little bit about storage intelligence, two-dimensional magnetic recording. There's a lot here around hard drives. Of course, helium, shingled magnetic recording. How many are familiar with multi-link SAS? Okay. SAS gentleman there. Multi-link's been around for some time, but it allows you to have a much wider pipe to get a lot more bandwidth capability. Multi-actuator, MAMR, HAMR, and hybrid SMR. So SAS SAS takes advantage of all these technologies, and so there's still, the message here is that there's still a lot of innovation going on in SAS. From a roadmap standpoint, we are in the process of readying 24 gig SAS to come to market. There was a plug fest back in June, starting to ready the ecosystem for 24 gig SAS. In particular, also from a drive perspective, I do work at Toshiba, and at Flash Memory Summit we demonstrated 24 gig SAS drive. There's lots of other ecosystem companies that have components ready, and we're expecting in 2020 for products to start to come to market. Now we have 40 gig SAS, 48 gig SAS on the roadmap. That is still being planned, but we're going to see how 24 gig SAS goes and the adoption rate, as well as seeing how the market adopts it, and or how many people migrate over to NVMe. So this is one of these charts that always stirs up a little bit of controversy, and it's subjective in a lot of ways, but it's just kind of a good, better, best between SAS, NVMe, and SATA. From a performance standpoint, I think we all know that NVMe devices have the highest throughput, lowest latency, highest IOPS. Where SAS really tends to shine is going to be in the scalability and flexibility, because today, SAS is, even practical deployments have gone out to hundreds or thousands of devices in a single system. NVMe is definitely better with NVMe over Fabrics. So now it's definitely you're able to do architectures that are pretty similar to what SAS does today. SATA is only good because it sits on a SAS infrastructure. From a flexibility standpoint, again, SAS can work with SAS and SATA hard drives and SSDs, and we know that NVMe does SSDs extremely well, and we kind of hear maybe some NVMe hard drives, but there are none that are available on the market as of yet. Manageability and hot plug, SAS has been doing that for a long time, and NVMe is definitely getting better, but it does take time for these things to mature. Reliability. SAS and NVMe are definitely better than SATA. And from a system cost standpoint, we all know that SATA is the cheapest. But SAS does have something you've heard of, which is called value SAS, which is a single ported version of SAS that basically is at a similar price point to SATA. So that may be something that's going to extend the life of the SAS protocol and SAS components for some time. And the roadmap, SAS going at least planned through 48, and I think NVMe has the longest roadmap. But I think, as mentioned before, SATA stops at the current generation. So this is one of these slides that, did you know? The SCSI command set is like very, very pervasive, whether it be parallel SCSI with Ultra 160 or Ultra 320, as well as serial attached. But fiber channel, USB, yes, your USB drives utilize SCSI commands. InfiniBand, FireWire, and of course iSCSI, all utilize the SCSI command set. So this is, it's been widely adopted. The SCSI command set has been adopted and utilized by, obviously quite a large number of technologies. Does Was there anything new on here to anybody? And actually, for my last slide, this is a little quicker presentation. The last bit of what the status of 24 gig SAS, the ecosystem, analyzers and drives and cables and connectors have been tested. They're available now. The cable, well, I just mentioned cables and connectors. Controllers and expanders are going to be aligning with PCIe Gen 4 platform launches coming very soon. And there are the new hard drive and SSD capabilities that are going to intersect with the upcoming 24 gig SAS ecosystem. And with that, anybody have any additional questions? So, question.
Well, I was talking to you beforehand, but what is the future of dual port SAS? Do you think?
While SAS is still an in-demand technology, there's going to be that higher-end dual-port SAS, and then that single-ported value SAS. So that will remain, part of SAS, at least from our products, from a Toshiba product standpoint. And as far as the SCSI Trade Association is concerned, that is the traditional SAS specification. So dual port will always be a part of SAS.
And value SAS is being worked on by SCSI Trade Association?
It started out as a Toshiba thing, but we're looking at having a profile, a specific version, maybe called server SAS or maybe called value SAS, but something that's a little bit more targeted at servers. One of the interesting things about SAS is that it has been basically one drive, one size fits all. And if you notice that, of course, NVMe has 1, 2, 4 lanes, different power envelopes. There's many form factors so that you can get very, very application specific. Where SAS basically has been a one size fits all. So it's very late in coming, but if you're getting kind of branching out to something that's a little bit more at least use case specific, that's where value SAS or server SAS is coming into play.
So what's the motivation for bifurcating at this point? I mean, is there actual cost? Is there actual physical cost savings, or is it just a differentiator for something to replace SATA?
So with the question being why?
That's a tough question.
Right. Well, making a single ported drive is cheaper. Of course, from a controller standpoint, the controller itself is less complicated. You don't have to support things like T10 diff, kind of data protection like you would do on a dual ported drive. So the controller is cheaper, it's less complicated, but also the test validation matrix is a lot smaller. When you think about when you're testing a single ported SATA drive, there's not too much that you need to test with it. But if you're testing a dual port SAS drive, you have to test it behind expanders, nested expanders, dual initiator, dual active or active passive. So the test matrix becomes much smaller and much shorter, so that you can actually bring it to market more quickly. Any other questions? Okay. Well, thanks everybody for coming. I appreciate you joining and participating in SAS. SAS is not dead, at least not yet. But thank you all for coming, and enjoy the conference. Thanks.